find the eigenvalues and eigenvectors of the given matrix. So here's the given matrix A, and you have to find the eigenvalue for this matrix and eigenvector as well. So first of all, you need to find A minus lambda I. So what is lambda I? Lambda I is lambda times the base matrix I, which is this one, lambda times base matrix, and you have this one, okay? So matrix A minus lambda I, which is you take this matrix minus this matrix, and you got this one, okay? And then the next step is to find the determinant of A minus lambda I there. So you just have cross multiply, subtract, cross multiply, okay? -1 times minus lambda times A minus lambda minus 2 times -7, okay? Then you work this out. So you solve for lambda. So after you simplify it, you got this one. Then after I put it in factor form, I have this one, set this equal 0, and then solve for lambda. I got lambda equals 1 and 6. Okay, so for each case, because this is a 2 by 2 matrix, I will have 2 eigenvalues for lambda. Okay, so let's solve for each case. First, let's take a look at the case where lambda equals 1. So when lambda equals 1, plug it into here. I have -1 minus 1 gives me -2, 2, -7, A minus 1, 7, and then you augment this matrix with 0, 0. Then reduce this down to use Jordan elimination. So make this matrix, make this entry becomes 1. So you have you divide the first row by -2. I got 1, -1, 0, and then multiply the first row by multiply the first row by 7, and then add it up onto this row. So -7 plus 7, 0, -7 plus 7, 0, 0, 0, okay? Right, now you see that you have a indefinite answer. So this is your let's see, okay? So you have dependent value, dependent solution. Okay, so this is a 1k1. Let's call this k1 and this k2. So you have k1 equals k2. Okay, so let's choose. So because this you can choose k1 equals 1, 2, 3, 4, 5, but I like to choose the smallest one or the standard one, which is 1. So if I let k1 equals 1, then k2 equals k1, which is 1. And then my eigenvector for eigenvalue is 1, 1. Okay, so if you choose this 2, then you have eigenvector of 2, 2 for lambda equals 1. Okay, so it really depends on what k you choose. But once you get up to this point, your answer is correct so far. Alright, so vector k equals matrix 1, 1 is your eigenvector of lambda equals 1. Now let's do the same thing for lambda equals 6. Okay, so lambda equals 6, you plug 6 into here, and then simplify this. So -1 minus 6, -7, 2, -7, 2, and then augment it with 0. So you see that you have this matrix, these two rows are identical. That means that you will have indefinite solution. Okay, so I have -7 k1 equals 2 k2, and then I solve for k1. I got 2 over 7 k2. If I choose k2 equals 7, I got k1 equals 2. So the reason I choose k2 equals 7 because I want to get rid of the fraction here. Okay, then my eigenvector for lambda equals 6 is 2, 7, the matrix 2, 7. Okay, so that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.